Okay, to this video we're going to look at an application of a polynomial inequality in which we are exploring the position function for a free-falling object near Earth's surface. So essentially what we know is when we launch things they go up and they come back down again. And so we have, as a matter of fact, a model that works very accurately for objects very near Earth's surface, in which we say that an object that is falling or vertically projected into the air has a height above the ground s of t in feet, given by this equation where v sub 0 is the original velocity. We're going to refer to this as the initial velocity, and we say, and that's in feet per second, and t is the time that the object is in motion in seconds. So we have t as our time in seconds. Lastly, that s sub 0 is our original height or initial height. So maybe we say, just like a few notes here, we say this is our initial velocity. And I'm just going to write initial v. You write velocity on your paper. If you're taking notes, we say this is initial height. I can fit this one in here. And so the reason why they get these little subscript 0 is basically because if we were to say initial height, we would say, well, what time was the initial height? We say, well, at time 0, basically. We'd say before we started the experiment, not before, but basically at the inception of the experiment, we could see that we get negative 16 times 0 seconds here squared plus v sub 0 times 0 plus s sub 0. And basically our model, what you can see is that these terms drop out and we get our height at time 0 would be given as this s sub 0 right here. So basically we have height of an object at any given time, so long as we're talking about on the Earth's surface. We're talking about our height is in feet and our time is in seconds. So let's label a few things here. We know that time would be our independent variable down here, and it's kind of like our x variable, but I think in this case I'd rather use t. And then we would say that what we have right here is the position of this object, or the height at a given time. So what we're looking at here is this model of a parabola that just kind of does this right here, and it's telling us the height of this object at a given time. So a few things we want to comment on here. We would say that as time is equal to 0 right here, this is where our initial height occurs right here. So we'll make a little note here that at time 0 we are at the initial height s sub 0. And another thing I want to note here is the fact that our a value here is negative. So basically this is a downward opening parabola where it's max height and time. So we say time and height at that time. So we would have max would occur at the vertex, basically. Now we're not after the vertex in this problem. What we're after in this problem is going to be something else, since we're talking about polynomial inequalities. So we say an object is propelled straight up from ground level, so this is our initial height here, our s sub 0, with an initial velocity of 80 feet per second. So we have our v sub 0 here. We say its height at time t is modeled by this. So we have our height at any given time in seconds is given by negative 16t squared plus, where you see they've inserted 80 for their v sub 0 here. And then we said ground level. So ground level, I mean, if you interpret this, we would say 0 feet off the ground. Plus 0 would mean that they've just completely left off this term right here. So we say here's our function where we have a height at a given time. And maybe we write this down here. Our x information is a time, and we'd say that our y information here is a height at that time. So what's the question we want to answer here? Well, it says, in which time interval will the object be more than 64 feet above the ground? So what I want you to notice here is this. I've been given a position. This is a height value here, but I've also been given this phrase more than. And so what we're really going to do is this. We're going to say we want to find the times. We're going to go look for time for which our height function is more than 64 feet off the ground. And we said more than, not more than or equal to, not at least, but we said more than 64 feet off the ground. So what we're going to do is this. We're going to take our position function here. We're going to plug it in to this expression. We're going to solve it, basically. We're going to say negative 16t squared plus 80t. So here we go. We know that we need to get the right side having the 0 here, or at least one of the sides having a value of 0. So bringing the 64 back over here, we say greater than 0. And if we're going to solve this here, I suppose the first thing we need to do is find our critical values. Now I didn't leave you a spot to write this here, so I'm going to go ahead and set this over here. And we're going to say we're going to set this equal to 0. We're going to find the zeros of this function right here. So I noticed that 16 is a factor of 16 and 64. 16 is also a factor of 80. So we're going to factor out a negative 16 here. Interestingly enough, it is. we would say this would become minus 5t, and this would become, I think, plus a positive 4 equals 0. So factoring this completely, I suppose that we would want to factor these here when we say, I notice that, at least I notice here that we get, supposed to be negative 4 and negative 1. So solving this, or at least carrying away the factors that have t's, we would say either t minus 4 equals 0 or t minus 1 equals 0. So t equals 4 and time equals 1. These are our critical values right here. So I don't have a lot of room left, but how about underneath this? What I'm going to do is I'm going to set up my graph and my test intervals. So we say 0, 1, 2, 3, 4, and we'll write 5 here. So our critical values occur at 4 seconds and at 1 second, essentially. And if we were to say, kind of arbitrarily up on this graph over here, if we were interpreting this as like 1 second, this is like 4 seconds, you could see how our graph, if this is like a height of 64 right here, you don't have to write this on your picture, but we would say between these two times right here at 1, 1, and 4, we would say we'd have graph values that were, maybe greater than a certain y value there. So that's what we're looking for here, and I can imagine that they would occur between 1 and 4 seconds. But what we have to do consistently here is choose some test values to plug in. So I'm going to test x equals 0, x equals 2, and x equals 5. So I put boxes around all those. I really probably shouldn't have. But plugging these into the original function, what you're going to see here is this. Let's go ahead and do this. I'll quit out of this menu here. Whoops, quit. And so we have negative 16, and our test values here are 0 is one of them. So I suppose plugging in 0 into our initial inequality, this guy right here, this is our initial inequality, we get negative 64 is greater than 0 because these two terms would drop out by plugging in a time of 0. So that's false, and so I know that I'm not going to choose that interval in terms of my test intervals from negative infinity up to 1, from 1 to 4, and from 4 to infinity. We're not going to choose this time interval from there to there. If we were to now plug in, I suppose we would say negative 16 times, and we're going to plug in 2 in our middle interval here. So we have 2 squared, and this is plus 80 times 2. And we have minus a 64. So minus a 64. We had 32. And so if 32 greater than 0 was our statement, we would say that this would be true. We're going to say that all of the interval or times in this interval here from 1 to 4 seconds would satisfy this initial inequality. So I'm going to put a box around this, and I'm going to go ahead and acknowledge that this last interval reasonably wouldn't work on this problem here. But in terms of solutions, the thing is here for solutions, we have our solutions between 1 and 4 seconds. And we shouldn't include 1 and 4 because this was only a greater than. And then the last thing, because this is an application problem, we should write a conclusion statement. So we should say the object was above 64 feet between 1 and 4 seconds. Cheers.